Hello everybody! Basically, I failed for 2 weeks in a row. Yay! So the idea is very simple indeed. So I want to take an image in the Quest, so take the camera of the Quest and send it to another PC. For the people on the other PC to be able to see the user playing, but not the view of the user, but a camera in the scene that is looking the player moving around. Seems legit. The problem is that I try for so many times and I failed and I failed and I failed. So basically, when you want to do that, you want to send an image through the Wi-Fi to another PC. This image do 4.6 megabytes, so very huge because you need to send it at least 20 times per second, and you should send it 30 to 40 times per second. So it means that you need to send 100 megabytes per second to the other way. Very, very impossible. So what you want to use is something that compresses this image and send it to the other way. So I can use compress the image into a JPEG and send it. So basically it's what I wanted to do, but Unity don't have a tool that allow you to compress the image quickly and to send it. And more than that, the compression of the image given by Unity compress the image on the main thread. So it means that while it's compiling, you cannot make your game turn. And on Oculus, you need 60 frames per second. So not a viable option. So maybe there is a library, I don't know, that allow to stream the image from the game to the outside. If someone finds the solution, make a comment here below. Help me, please. Thanks. But firstly, do it, because most people say, yeah, you can just do that, but when I do it, it's not working. So if you propose a solution, you propose the solution, not the idea of the solution. Thank you if you are looking this video. So this video is about explaining my 2 weeks of fail for me in the future, because I know I can solve this solution if I find a mathematician that want to work on the solution, or if I use machine learning, there's maybe a solution to this problem. And if you solve it, basically it's amazing for everybody in the world. It's why I'm doing this post-mortem after this project. So, a bit of explanation. If you are here in the video, it means that you are interested by the subject. You want to know how we can compress an image from the Quest to another PC to be able for people to view, to see what people are doing in the Quest, okay? If you are liking this subject, it will be a long video because it's a post-mortem. It's me explaining how I failed for 2 weeks, okay? Keep on it. Let's go. So, what is the idea? The idea is kind of simple. So, you have an image produced by the Quest. We don't want this image. We want more this image. So, we have a camera in the scene. This camera is producing 800 multiplied by 600 pixels. But as we store the image like this, it makes a lot of digits and a lot of information to store. So what we want to do is to put every digit one behind another to make a big number. Why it's stupid? It will say because you can send the information directly in bytes. It means 10101010. I will say yeah, it's true, but follow the next part. So if I took all these pixels, convert them to a number, we have like 5 million digits to convert to something smaller, because here we have still 4 megabytes of information. So all this number, if you put it on the GPU side, maybe, and that was my hypothesis, that my idea that I tried for 2 weeks, we can convert it to a mathematical equation, like A exponent B plus C exponent D plus E exponent F plus the rest. In the idea, it's working well. In the practice, you can understand that it's another level of masochism. But basically, if we succeed to do that, it means that we have this number here making this line. It means that a lot of number, like 300 number, 300 digits, can be converted to 5, 6, 7, like 20 digits. So it makes a compression of 90%. In theory, practically, it's really, really hard. And I think that without a mathematician or without machine learning, impossible to do it because you really need to. It's really complicated. You will see. You will see. So I also invented something that I call the base Chine. So basically, I take 0 to 9,999 and I convert those number into Chinese symbol. And like this, it allows me to convert something that make 4 digit to 1 digit. In theory, it was cool, but at the end, I realized that 1 digit it made 1 byte, and 1 Chinese symbol it's 3 bytes. So basically, I convert 4 bytes to 3 bytes. Yoo-hoo! I compress from a quarter of the size. Yay! So this formula, I can send it to UDP to the other PC, and then I just do the mathematical equation in the other way. It means that I take the Chinese, I convert it to the formula into the big number through the GPU, and then convert the GPU value to pixel value, and ta-da! You have the image in the other way. So basically, the idea is quite simple, but it's in the practice it's hard. So to make you a bit more understand what I mean by this formula, I have done a game that allow me to try a bit the idea. So for example here, max to play here. So it's kind of simple. So for example here I have 0910010. So the game is you need to why it's not moving? Okay. You need to find a way with a exponent b to arrive to this number. So we can see that it is 1, 2, 3, 4, 5, 6, 7, 8, 9. I will change the number because start with that is not easy. Pam 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 pam. Scene. Hop. 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 I will put 42. The answer of life. Hop, play. So we'll start with small number. 42 is, for example, 3 exponent like this. 4. 32 plus 10. Ta-da! So basically I have 2 exponent 5 plus 10 equal 42. So here there's no compression, but you can understand that if I go with some other number, you can see that it make huge number. As you can see, you need to use big integer, and big integer it's something that allow you to make a very large number computable by the PC. But once again, I had a problem is that it worked super good on the CPU, but not on the GPU. So it worked, but I need to find some ways. So we'll try with this number. So if I want to have 700, I will say pop, 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 pop. Here, some people that are good at math, they are just going crazy saying, do that. Okay, you can see that it's not so such easy solution because you see there is some gap that you can try that you need to fill, and most of the time it sees that will allow you to adjust the gap, and if you use C, it's a bad stuff because you need to have a low number that you will need to reconvert. But that's the idea. How can I find this number? Up. On était presque. Yeah, I'm not using remove, because if I use remove, it means that I need to store another data. And that's my problems. So you can see that basically it's kind of easy when you play with it, and it's why I did a game to understand a bit how it's working. It's not so easy to find a good number. So what I did is I did a lot of tests, save. And mainly I follow on this website that is called Matfofen. Matfofen. Algorithm. Yep. Okay, so basically it's explained that remind you that exponent mean 2 exponent 3 is 2 multiplied by 2 multiplied by 2 equal 8. And basically if you want to do the other way, you can do log of the base you are using and the exponents, the number you have, and it will give you the exponents you need to arrive to that. So I was like, oh, nice. So I did a scene with a lot of experimentation. You will see that. For example, here, find the base A exponent B. So here, I just give a number, for example, this one. I say that the base I want to use is 9999. And here you can see that he can already say to me, yeah, it's 9999 exponent 11, and you will succeed to have something kind of that. But as you can see, there is a rest that is a bit long. So here, if I remove this result, I will have that as rest. So I have no compression here because it's kind of the same number between this one and this one. So basically it's this one less this one equal this one. So if I press play here, so basically he will start, yeah, max to play, I will remove that. Wait, this. Hop. So here you can see that this tool, it's allow me to it allow me, for example, to find the best solution. So here he will try to use a lot of number between 0 and 99999, and it will find the best solution. For example, here you can see that if I use this number exponent this number, I have a compression of 2 bytes, of 2 digits. Now he find a new one at 12, so I have 3 digits less. And for the next one, I will move a bit here. Here. So the best one here for is this number exponent this number, but you can see that here I'm using another base, not 99999. So if I want to use 99999, I should be here. But so yeah. So basically here you can find the best exponent to be removing that. So if I use this formula, I could succeed to do something like this. Number to power exponents, I think it's this one. Yeah. So basically you give a random number here. Okay. Then you say just that you want to find what it will give with this base. For example, if I use base 9999, so a Chinese symbol, I can use base 6 if you want to use hexadecimal, base 10 if you want to use decimal, but here it will just write the number. 64 if you want to use base 64, etc., etc., etc. So if I say compute that, you can see that here, basically this number is equal of this number multiplied by 9999 exponent 4 plus this number multiplied by 9999 exponent 3. So basically, if I want to store this number, it looks like this formula. That is longer than what we want, but if you remove this to put them one behind another, up, 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 and those number you change it in Chinese symbol, for example GHGG. You can see that instead of using 19 digits, I can use it 5 digits. So that the basic idea of compressing the big number in a small one. And as you can see, it's kind of working, kind of. Yeah, wait, it's not working again. Yeah, the big problem is not here. Indeed, it could work based on what I find this last time. Okay, I will look that later. The reason why I do a post-mortem is also because it helped me to find the solution by explaining you the solution. So basically, you are my plastic duck. If you don't know what is a plastic duck is, go look on Google. It's a fun story. So here, I can convert this phone number to Chinese symbol. You will say, what? Chinese symbol? What he's speaking about? And then I can show you that. So remind you that basically what I did this. I convert to a formula. I just use this to know which number. Those I don't care because 999 is the base I'm used for every compression, so I don't need to store it. And is here why I don't store 4, 3, 2, 1, and 0 is because it's 0, 1, 2, 3, 4. So I just need to store that, and bam, I'm done. The Chinese stuff, it's because I create something that is called the Unicode base ID here. So just to show you a bit, it's crazy good, but apparently it's not saving a lot. Basically, you come here and you say, I want base 60, for example. So I will say use a base 60 heap. So I say I want this number in base 60, and it will convert it to hexadecimal. But basically, you are not obliged to use, because based in mathematics, if you don't know it, it means that base 2 is 1, 0, 10, 11, 100, 101, 110, 111, and blah, 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 blah. Base 10, it means 1, 2, 3, 4, 5, 6, 7, 8, 9. Base 16, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. A, B, C, D, F, E, F, and that's what we have here. But if you want to use a base chess, you can take a base chess and put it here and and it did not work. It's because base chess is not loaded with chest. Chest save. Ta-da! So basically, this big number worth tower, 2 queen, and no, 2 king and 2 queen. Oh, I don't, or the other way. So basically, here I do a conversion of 1. So no conversion here. It's because I'm using not a lot of characters, the same kind of number than in real life. But if I use now my base Chine. So I say use my base Chine, play up. So basically, if I do 1, it will give me this. If I use 10, it will give this. 100, it will give this. 9999, this. 9999, sorry, this. And if I do more than 99999, like this, then I will have the second number. So that's how base work. So if I use this huge number that is making 40 of length, I have this Chinese symbol that make 10 of length. Basically, the idea is really, really amazing, and I was using it massively in my program to store less data. But then I realized, like I said, that this was 3 bytes, and this means that I stored 3 digits. No, this was 3 bytes here. So this one take 1 byte. So it means that I take 4 bytes, I convert it to this, so I just win 1 byte of data, and that's lame. I'm so sad because it's crazy to convert big number in small number. For Twitter, maybe it can be useful. Okay, so basically, now that you understand that you can convert a big number in a small one, if you use a base that is very huge here, like here I use this kind of number, just to show you a bit what look like the base Chine. I will save it here, and I will oh yeah, I can show you source Chine. So why Chine? It's because it's a file composed of all the Chinese and the Japanese character to speak, and I use it as a number. That's stupidly fun, but it worked very well. And why South is because I'm also using South Korea character. Why I'm using those and not all the Unicode is because I know that every computer should be able to render Chinese, Korean, South Korean, and Japanese character. So it will always work. It will always be storable in a wiki, in a program, everywhere on the world. If I use a more specific, it will make bug the application. For example, this one, it's not working on every PC. It's not displayed on every PC, so it's useless. And this file suits Chine, it makes this number of characters. So you could say, yeah, it's better to use 38,000 of number instead of 99999, but it means that this part there is 5, 6, 7, 8, and 9 that is not used. And so basically it's better to use 99999 than this one. But yeah, hard to explain. Ask question if you're interested on this subject. I will continue. So basically it means that you could send, instead of sending a very huge number to your friend, you could just send it's fun because you could just send a exponent that plus that. Ta-da! And instead of having 200 digits, you have 3 digits to store. Crazy good. Okay, but in theory, but in practice, it's not working, as you guess, as I said that since the start of this video. So what did I try? I will try to explain you a bit what did I try to make you able to work on it. So for example, I was wondering, okay, if I use the GPU, so the graphic card, and I cut everything in small parts that is computable by the graphic card, how many parts do I need? So if I have 800 on that number, that's that one. And so I store that on 255 multiply by 3, it means 9, because my friends say, yeah, but you can use this, you can use something like that instead of that. So yeah, it's true that I could store less number of pixels like this, and we don't lose so much. But yeah, so that was that's why it multiply by that 8 of image, multiply by 9 digits to store the color, make this number. So if I split it by the number of 400 by length, and I succeed to compress that, it make 1000 small formula to store on the hard drive. So 30,000 character to store instead of those numbers. So the compression would be kind of really good indeed. Not perfect, but kind of really good. If I take more, I can do less formula to store. Or if I decide to use the stuff of my friends, it would mean that now I just need 3000 formula of compressing number of 1000. So we'll try to be realistic. So here we say 200 because I know I can succeed to do this number. It meant those number of formulas. So you see, you can try to tweak the compression to make it work better for the Wi-Fi. But still, if we have this compression that is, for the moment, yeah, like 200 to 300 times more compressed, it would be amazing. Even if it's 10 images per second, a compression like this would be amazing. So now that we know that we should implement that, I did try. So the first thing I did is this script. So basically, if I activate it, if I press play, and so it take this number and it try to figure it out what it means to say this number 2 to 3 min number max number it tried to guess from this number to this number what it means. So for example, if I use if I use a base from 0 to 99 and I want to go from 2 exponents to 11, so like this I can store 9999 exponent 9 exponent 11, because we don't need the 0 and the 1, as 99 exponent 0 is nothing, and 99 exponent 1 it's 99, so we don't need to use it. So I can go until 11. So if I say play this, it will compress everything. So as you can see, there is a lot of data to store. Why it's going up? Yeah, no, it's okay. So you can see that like this, you can have a file to be able to understand a bit more what is the gap between the number. So we'll stop here. So it looks like this. So I will try to zoom for you. So we have, if I use this number, so 271 exponent 4, I will have this number. So for 4 digits, I can store 10 digits. Okay. So if you go forward, here it's, yeah. So if I go to 99, we'll try the best one. So for example, if I go directly to 11 with 99 and we press play, here we'll wait. Hop. So you can see that here, if I use 99 and 11, I can compress a number of 33 to just 5 digits. And those digits, if I convert it to Chine, so it means the Chinese character, or if I try to convert it in binary, it means that will take a less size. For example, 11, it's in binary, it's technically it would be something like one ship. I don't remember which one, but it's something like that. But as 11 is stored in Unicode, it's 000 and 1, something like this. So it means that here it's 1 byte for just one number and another byte for the next number. So it means that here for 11, I'm storing 2 bytes. Okay. And if I try to take 11, but instead of using Unicode, I'm using directly the number that I send through UDP or in the file, I can use, like I said, something like one like this. No, occupy. So when you have that, it means that you can compress the number very. Just a break because I cannot think when my mother is taking the PC next to me. Run, run! Yeah, I know, it's okay, it's okay. Sorry for that for people that are looking the video, it was a break. Yeah, I should put some sign on my door. So yeah, so here it means that this huge number that is taking 33 digit multiplied by 33 digit and so 30 bytes because of the Unicode can be converted to maybe 3, 4, 5 bytes. I don't remember which one, but basically it's convert up 99 to digit to 10. So as you can see, it's not so easy to remember how many 999 is worth in binary. So what I did is this tool. So here is I put 99999. I can store it on those numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So yeah, like it's put here. So it means that I can store it in 2 bytes. I don't know why it's put 1 because it's 2 bytes here as I'm going up. And the 11, if I put 11, it means 1, 2, 3 bytes. So here, this number, I can store it on 3 bytes instead of 33. Nice. So it makes a compression of 30. That's amazing. If we succeed to do that, it could be 30. But I'm forgetting also that there is a bit more byte because don't forget that there is this number and this number, and there is a huge gap, as you can see, between this one and this one. So I wanted to feel how many do I need, because here I need to add C between to be able to adjust from one another. And so how high is this C worth? And so I did a script that do that. So where is the bridge? Max length. Yeah, this script is just to remind you that if you don't want to use big integer that is dealing with huge number, you can use byte short, int integer long. You can see that when you are working with big number, primitive number is so small, it's ridiculously small. You can use u short, you can use float, but float, once again, don't forget, if you don't know it, that a float, it store like 8 number, I think it's 7, then it multiply by 10 exponents another number. So it means that when you use float or double, you lose some data. Or here in our example or in our solution, we cannot lose one data, because one data, it makes some pixel weird, and yeah. So that's the very big part of this solution. You cannot lose some data. So no float, no double. Some exception, you can use it in some exception, but you have to know what you do. So yep. Just to remind you what we are dealing with, here is a number by mean of length. So we try to convert that to a small formula, but we should be able to convert that. And if we need to use a bigger number, I think that we will just use 2 times this one, or 3 times this one, etc., etc. But here is some number to make you feel a bit what it looked like. It's huge. If it works, it means that maybe we could convert this big number in in something exponent something plus something, like 7 character. It would be amazing. So so I said the problem is that there is a bridge between the exponents. So what I did something that is research and development, where it says. So to understand the bridge, I did this. I will go to the solution directly. So because this video is kind of a bit long, I don't want to bore you to death. I did this. So those 5 stuff here allow you basically to take every exponent, you take lot of number exponent, lot of exponents, and then you have the formula and the answer. So basically I take everything, I fuse that in one file, I remove every part where there is 2 times the same formula because of bug possible. And then I sort every formula by the results. And so it gives you this kind of file, where basically more you go down, more you go to result that is higher. In the solution, I have a version where it's stored by length. It's easier to find equation, for example. Because here, if I want to find a formula that using 30 of length, it's not stored here, so you cannot see it. But basically, it means that if you do that exponent, so this number 4000 something exponent 9, you will have this result. And the gap here, it means that if you want to go to the next one, so this one, okay, there is no exponents, no formula that will fit in all those next number. So you can feel that if I use a exponent b plus c, the c is very, very huge. And so it's not working well. That's where I need a mathematician to find some formula. For example, I don't know, a exponent b multiply by c plus d. Maybe it will make the c less big. And so if, for example, we succeed to take a formula and transform the c in half the size, it means that we can have a very good compression from formula to formula. So here, if we just remove some digit, it's not worth it. And so that's what I find with this file. It's that more you go in the exponents, more the c is evolving. And I was thinking maybe this number exponent, this number in some occasion would make small rests, but that's not the case. Maybe with primitive number, but else that's not the case. And so I cannot use it. For example, here, if I do this number multiplied by this number, it's perfectly the good number. And so there is, I said nothing. Here it's just saying that we have 2 formula that have the same number. So you can use this one or this one. But if you use this one, Po10 mean that you need to do 5 times more the computing part, because you need to do 98 multiplied by 98 multiplied by 98 10 times. So yeah, that was really a bad news for me, because when I saw that, I was like, oh shit, it will be impossible to convert that to small formula without the formula being more high in terms of storage. Because here, if I want to do this compressing to this, and I take this formula and I compress it and I compress it and I compress it, mean that I need to use like 7 or 8 digits, and 7 to 8 digits to convert something that is already making 30 digits. It's, I mean, because no, 8 number, because you have 99, you have like 4 digits plus 1 digit, so it means already 5 digits. If you do 5 times that, it's 25 digits. For 30 digits, it's not worth the compression. That's why I'm a bit sad of this story. Okay, so I will stop whining about this, whining. So basically, this tool allows you to do what I just showed you. I can show you that in another video, but for example, can maybe show you this one. For example, up. Yeah, understand the bridge here. It's kind of cool tool. Maybe I can show you. So basically, understand the bridge. It allows you to just see here, up. So if I use 99 exponent exponent 6, it means that I will have this number. Yeah, sorry, it's a bit small on your PC, on your screen. I'm not saying to screen a bit more. Yeah, but basically it means that this number exponent 6, 99 exponent 6 will give this number, and the next one, so it means that if instead of using 6 I'm using, for example, 7, it's at those distance. So it's how I more or less do that. So here, if I want to show you a bit a tool to be able to generate this kind of file, I just need here to press play. Here I'll deactivate it. I make play. And here it's basically here it's computing every number between 0 and 99 number and the exponents, and it's storing that in a file with the length of it. So for example, I say, okay, it's cool, you compute enough. I can go back in show in Explorer here. And you can see that it's creating some file with the length of the compute number. Here it's empty because I did not let him compute a lot. 5, it will be not empty, I think. Okay, here. So for example, here, for every number that was 5, you will have a file with the result and the formula. So it's that exponent that equal that. So it's kind of super useful when you want to practice the idea of compressing numbers. So I did try to use a database of all these numbers and try to find the best number and use it to compress the formula, but still it's a lot of megabyte to store in your project, and it's not worth it. So, and if you use it in a database, it means that it will become so huge that you will have a time between the requests, and so it will never fit the 30 times per second. So I was like, work but not work. So here we are with me blocked, not understanding in which direction I need to go to compress those number. And why I'm very, very sad about it is because the compression is not applied just to image. So basically, for example, you want to send. I see if the look if the Oculus one is here. Oculus. No, it's not on this project. I think it's in another one. But basically, it means that, for example, if I take the Oculus and I say, is the button 1 is pressed? Yes, no, 0. The button 2, the button 3, the button 4, the button cancel. Pop up. And then I say, okay, what is the X value of the joystick here? So I take the joystick, hop, I say X value. So the value means 0.789, for example. So what I do is that I just do whoop and whoop, okay? And I use 1 or 0 to say if it's negative or positive. Put it like this. So I use the Y now. So Y is 0.999. So I do pop, pop, pop. Then I remove that. And as it's positive, I put 1. Ta-da. And you can see that basically I can take all the information of this controller, put it in a large number like this, pop, pop, pop. And so, for example, we can say that the Oculus value actually was this big number. And so if you could use my algorithm to be able to compress, it means that those number will maybe worse that exponent that plus that exponent that. Hop, I don't know, plus that. As we are using a base 99, we can convert that to a Chinese symbol, exponent 3 plus a Chinese symbol, exponent 4 plus Chinese symbol, and that's all. So it means that you could have this to send to the other PC, and as we know that it's plus plus, it means that we can do that. We know that it exponents, so we can do that. And ta-da! So it means that a very big number can be converted to just that. That's crazy! That's crazy! So it means that even if my goal is to take an image and to stream it to another device to be able to show people what is inside the Oculus Quest, the resolution of this problematic with machine learning or mathematician could allow us to store very, very, very big data through the GPU in no time and send it to UDP. It means that if you do, for example, a game that is using 100 player, instead of having 100 players sending a very huge number of data through the UDP, you just have 100 players sending 5 characters through the UDP. So it means that you win in bandwidth, you make people less wait for the computing part, you win some storage, yeah, it's a win-win solution. So I will stop there because I can speak a lot on this project, explaining my concept, my idea, and how I can try to solve that, but it's useless because I know that not a lot of people will look this video until the end, sadly. But at least me, I will look it later when I have some better idea, or when I when I will be able to use machine learning. I really think that we could solve this solution. And so this video is done for you, for if you want to solve it, but mainly for me, for be able to solve it later. So you, Eloi, in the future, if you succeed on that, GG, because it's really not an easy solution. But if you succeed it, I know that you did something good. See you. I say hello to everybody. I say bye to everybody. May the code be with you, and see you in the next video. Bye bye.